In today's class, we are going to take a look at yet another interesting topic called as valency. In our previous classes, we have studied the structure of a model according to Bohr and also learned that how the electrons were distributed around the atom. We also took a look at the rules for arranging the electrons around the atom. There were three rules. The first one being arranging the electrons in the lower energy shell. Second, to follow 2n squared, and third, that the outermost energy shell should complete its octet. Let's take an example of element sodium with its atomic number as 11. Now, according to the distribution law, the first rule what I need to follow is start arranging the electrons from the lower energy shell around the nucleus. So, the lower energy shell is K. Clear? Next, to distribute the electrons, I need to follow rule number 2, that is 2n squared. How many electrons do I have? I have 11 electrons. Now, let me see how many electrons I can place in the K shell using 2n squared. So, 2 times 1 taken 1 times 1 square, that is equal to 2. I have taken 1 here because K is the first shell. So, out of the 11 electrons, I can arrange only 2 electrons in the K shell. So, let me go ahead and arrange 2 electrons in the K shell. Now, since I have already arranged 2, I am left with only 9 electrons. Now, let me see how many electrons I can arrange in the L shell now. Following the same rule, 2n square, where n is the number of the shell. So, I am on the L shell, which is the second shell. So, out of the 9, I can arrange only 8 electrons in the L shell. So, let me go ahead and arrange 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. So, how many electrons am I left with? I am left with only 1 electron. So, 1 electron I am going to place it in the M shell. But what is the third rule? The third rule is the outermost energy shell must complete its octet. Now, here in case of sodium, the outermost energy shell is M. So, I am going to take away N. So, it has only 1 electron. Now, sodium is highly unstable because it has only 1 electron, because now it has only 1 electron in the outermost energy shell. It's waiting to combine with somebody else to become stable. Remember, when it has only 1 electron in the outermost energy shell, it needs to wait for some element which could give it 7 electrons to complete its octet. That's going to take a long time. All right. So, in this case, sodium would give away its electron to complete its octet. Hence, sodium combines with chlorine, giving away its electron to form sodium chloride. The common salt we eat every day is nothing but a combination of sodium and chloride. So far, it's clear. Now, let's come back to what valency is. The combining capacity of this electron. So, this electron in the outermost shell is waiting to combine with another element to complete its octet. To complete its octet, the outermost shell will either give away the electron or will receive the electron, or in some cases it would share the electron and see to that the outermost energy shell has 8 electrons. So, this electron in the outermost shell is called as the valence electron, and this shell, the outermost shell, is called as the valence shell. Hope it's clear. Let me go through it once again. The the combining capacity. Now, in case of sodium, it has only one. So, what is its combining capacity? It has the capacity to combine with 7 more electrons to complete its octet. But getting 7 more electrons is a very tough task. So, what sodium would do? Sodium would give away this electron to somebody else so that its octet is complete. How is its octet complete? Because the L shell already has 8 and it will lose the outermost shell by giving away the electron to somebody else. So who is willing to receive the single electron? It is the chlorine. That's why we always have a combination of sodium and chlorine together. In cases of elements which have 1, 2, 3 and 4 electrons in the outermost energy shell, such elements would give away the electrons. Let me repeat if it's confusing. So, is the valence and valence electron clear? The electron in the outermost shell waiting to combine, the electron in the outermost shell waiting to combine with other electrons to complete the octet is called as the valence electron, and the outermost shell is called as the valence shell. All right. In case of elements where the outermost shell has only one, 2, 3 or 4 electrons, then the valency of such a element is either 1, 2, 3 or 4. And these elements would usually give away the electrons to somebody else to complete their octet, or would share the electrons to complete the octet. But for elements who have more than 4 electrons in the outermost shell, they would try to receive the electrons from the other elements, and the number of electrons which they require from the other elements to complete the octet, that will be the valency of those elements. Let me make it clear one more time. All right, now let's look at it one more time. Suppose if the outermost shell has only 1, 2, 3 or 4. So if it has 1 electron in the outermost shell, it would require 7 electrons to complete its octet. If it has 2, then it will require 6. If it has 3, it will require 5. If it has 4, it will require 4 electrons to complete its octet. But getting so many electrons to complete the octet and to become stable is very, very difficult. So in such cases where the element has either 1, 2, 3 or 4 electrons, they would give away the electrons to some other element to complete the octet. How is the octet complete, ma'am? Because we have seen it in the previous slide that the lower shell already had 8. It was only in the outermost shell of sodium it had 1 electron. So it would give away that 1 electron to chlorine to complete its octet, because the L shell already has 8 electrons and sodium has become stable by giving away and combining with chlorine. So the valency, if an outermost shell has only 1, 2 or 3 or 4 electrons, then the valency will be equal to either 1, 2, 3 or 4, depending upon the number of electrons present in the outermost shell. But if the element in the outermost shell has electrons more than 4, then the 5 minus 8 would be the number of electrons it would be requiring to complete its octet. I've just taken 5. So if there are 6, then you would take 6 minus 8 and see the number of electrons which it would require to complete its octet, and the difference would be the valency of that particular element. For example, in this case, suppose if I had 5 electrons in the outermost shell, then this outermost shell would require 3 more electrons to complete its octet. So the valency of such an element is said to be 3. But if it is less than 5, then the number of electrons present on the outermost shell is equal to the valency of that element. Hope this is clear. Now let's move on. Next, we are going to look at atomic number. So atomic number is nothing but the number of protons in an element. The number of protons is equal to the atomic number of an atom. For example, hydrogen has 1 proton in the atom and its atomic number is 1. Sodium has 11 protons in its atom and its atomic number is 1. So atomic number is nothing but the number of protons. Electrons were not considered because the mass of the electrons were negligible. We have studied in our previous class that protons were very heavy and hence they added to the mass of an atom. So number of protons in an atom constitute the atomic number. Hope this is clear. Now let's move on to the next slide. What are the characters of the atomic number? Atomic number of an element is always a whole number. You would never see an atomic number of, say, sodium to be 11.2, or you would never see the atomic number of carbon to be 13.5. It's always going to be the whole number. And atoms of the same element have the same atomic number. So there will be many atoms belonging to the same element and they would all have the same atomic number. This point will become very clear when we understand the isotopes. An atomic number is represented by Z. So what is atomic number? Atomic number is the number of protons in an atom. We never consider electrons because electrons have no weight, or even if they do have mass, it is negligible. But through the experiments, we know that protons have a mass and that's why they were considered for the atomic number. So number of protons gives you the atomic number. Atomic number would always be a whole number and it is always represented by Z. Atoms of the same element would have the same atomic number. Clear? Let's move on. Good. Atomic mass. We have been studying that protons has mass. When neutrons were discovered, though they did not have any charge, they had mass and hence constituted to adding up to the atomic mass. So atomic mass of an element is nothing but the total mass of protons and neutrons. So what is atomic mass? Atomic mass is nothing but the total mass of protons and neutrons in an atom and it is represented by A, whereas atomic number is represented by Z. Clear? Okay. Now let's move on to isotopes. Now what are isotopes? Isotopes are atoms of the same element having same atomic number but different atomic mass. So what is an isotope? Isotope are elements or atoms of the same element which have same atomic number but different isotopes. For example, hydrogen has 3 isotopes: protium, deuterium and tritium. Hydrogen has 3 isotopes: protium, deuterium and tritium. You can see atomic number of hydrogen is 1, but atomic number of protium, deuterium and tritium are totally different. So these are called as isotopes. So what are isotopes? Atoms of element having same atomic number, that is same number of protons but different in their mass number, that is combination of mass of protons and neutrons. Clear? Okay, let's move on. I have some more examples of isotopes for you. Carbon has 2 isotopes. Chlorine also has 2 isotopes. Many elements have many more isotopes. You could take this as a research topic and find out how many more isotopes are there and you could post it in the comment. All right. Now, where do we use these isotopes? Isotopes are of great importance. Isotope of uranium, for example, is used as a fuel in nuclear reactors. Isotope of cobalt is also used in the treatment of cancer. An isotope of iodine is used in the treatment of goiter. You would have studied this in your biology classes also. Anyway, for the previous question, I've already given out the answer telling you there is isotopes for uranium, cobalt and iodine. You can find out what they are and you can post it in the comment. So isotopes are atoms of elements having same atomic number but different atomic masses. Now let's look at what are isobars. We know iso meaning similar. That's why we have isosceles triangle. Iso meaning similar. So atoms of elements having same atomic mass but different atomic number are called as isobars. Atoms of element having same atomic mass but different atomic numbers are called isobars. For example, calcium and argon. I hope you enjoy this lecture. Until you see me next time, bye bye.